Hey there, what's up guys? So today we're going to be looking at the ICStation digital buck converter. So as you can see, this little guy has a display on it. It has four buttons. It has some capacitors and this big inductor here. So I'm going to go ahead and unplug it and bring it up to the camera so we can get a closer look. So just looking at some of the circuitry here, it looks like here there is some kind of microcontroller. It's a microchip microcontroller. This looks like probably a buck converter controller IC, and that's probably doing the switching of the power that is going through the inductor to step the voltage down. We have some input and output smoothing capacitors here. Those are rated for 50 volts, which is good because the input of this I think is rated up to 36 volts. So that should be more than enough headroom on that guy. Over here we have an LM317. I should know what that is, but I don't. Is it a diode? No. That seems on. No, it has 3 pins. It's not a diode. Okay, so yeah, over here we do have a diode though. That's definitely a diode. Then we got a couple LEDs right here and here. And that's just going to be giving us some information later on. We'll see when I demonstrate how it works. So let's go ahead and do that now. This episode's mostly going to be data. I took a bunch of efficiency measurements of this guy, and we'll be looking at those at the end of the video. So I'm going to go ahead and put 20 volts into it. So it's set to 20 volts, and you can see it's remembered 9 volts. That was the last thing I had it set to. So that's very good. It has some kind of internal memory. So let's take a look at the functions. So over here we have on-off. So I can push that, and that turns on and off the output. Very easy. So again, sorry, it's hard to see the screen for you. I realize that. So 9 volts. 9 volts on the output, and if I push the on and off button, we get down to 0 volts on the output. Easy enough. Then let's go ahead and turn that back on. Then the second button is input/output. So if I push that, you can see we switched the other LED, and that's showing the voltage that's being put into it, and we'll verify that in a second with multimeter. So yeah, we can swap between the two inputs there. Okay, so 9 volts, we're looking at the output voltage. So if we go plus or minus here, I can adjust that in 100 millivolt increments, and it blinks for a sec, then it sets the voltage. So what happens if I put it on output and then push plus or minus? It seems to, or put it on input, sorry, and push plus or minus, it seems to still adjust the output voltage. So there's no input adjustment. I mean, that wouldn't make sense, but just wanted to see what it would do in that situation. And it seems to just switch back over to the output setting. Okay, so let's go ahead and just take a quick look at what kind of voltage we're getting on this. So I'll bring the multimeter in here, and let's go ahead and switch this over to input measurement. So it's reading 20.2. .35. So, you know, it's not super accurate, but that's all right. It's not supposed to be a multimeter. It's supposed to give a rough estimate. Now, the output voltage is reading 9.7. Let's go ahead and just put that on there, 9.9. That's a little far off. It's a little farther off than I'd like to see, but it's not unforgivable either. So let's go ahead and adjust this a little bit. And as you can see, it does not update immediately. It has to stop blinking first. And yeah, it does seem to be outputting a voltage that's slightly higher than what is measured on the display. So, and if I hold it down, it does go down in 1 volt increments. That's very nice to see. Good for them so I can move around quickly. And the minimum voltage is 1.2 volts, but it's actually 1.3 because, again, this is showing a bit low. So let's go up to the maximum voltage, which for us is going to be around 20 volts because that's what I'm putting into it. So let's just go up. You can see it won't let me select a voltage higher than the voltage that I'm putting in. As much as I push plus, it will not go any higher than that. However, the display reading and the actual voltage is putting out is significantly off at this point, which is not great, but what can you do? You know, this thing you can get on Amazon even for like $6. It's pretty cheap. I'm sure it's even cheaper if you buy it on ICStation's website. So that's a good look at that. Let's go ahead and take a look at the efficiency ratings. Alright, so here we are in Excel, and yeah, I wanted to just take a look at the efficiency of this power supply. So, as we can see up here, I took a bunch of data and I put that here into Excel. I calculated the efficiency at a bunch of different voltages. So I did 2 different output voltages. I did 1.1 volts and 9.2. 1.1 being the minimum and 9.2 being somewhere in the middle. So yeah, it was a little tricky for me to do this because I only I didn't like have a proper load, so I was just using a bunch of high wattage resistors, but they get really hot, so that's not ideal. So anyway, yeah, so we can see here that when it's putting out 1.1 volt, it's pretty inefficient. It starts out at, that's about 45% efficiency, and as we bring the voltage down, that was starting out at 30 volts going into it, and as we brought the voltage down, we had peak efficiency around 5 volts, as we can see here. And at that point, if we scroll up right here, we can see that it was 66% efficient. Then it dropped down to 63. And then after, this was about the lowest voltage I could possibly get it to before the whole thing shut off. So at some point, the little microcontroller in there just can't run anymore. I'm assuming it's a 5-volt microcontroller, and it just cuts off at 4.1. So that's the lowest voltage that you can run this thing. I wouldn't run it below 5 volts though, because that seems to be where it's most efficient. Assuming you're running the lowest possible output voltage, which is 1.1 volt, which I don't know why you would do that. That's not a very practical voltage. Oh, I forgot to change this title. Originally I only had one line on this graph, and then I added the other, so just ignore that chart title. So this blue line here is with 9.2 volt output and driving 11.9 watts, so 12 watts. Now, what we're looking at here is we're starting out around 84% efficient. Not too bad. I think that's respectable. They claim 96% efficient on their Amazon page, and I don't think that's honest. I think it's maybe an 85% efficient power supply. But certainly when the voltage is close to the input voltage is close to output voltage, so when I drove it down to, what was this, 9.98 volts, it was pretty efficient at 0.94, at 94% efficiency. So, you know, that's not too bad. I would say that's, I mean, if you're driving an input voltage that's that close to your output voltage, and why are you even using one of these, though? Even a linear regulator could achieve something like that. But I suppose this is better for high load applications. So, anyway, I think that's it for the efficiency graphs. I think they're respectable. It's pretty good. Certainly it's wasting some power on, you know, just driving the LCD and microcontroller and stuff. It's not ideal for battery situations, but it's not bad for using it on the bench. So,
that brings me to the price. Let's take a look at this. You can pick one of these up for $3.89. That's pretty dang cheap. And we can look through here. So as you can see, if I scroll up, my computer's running slow because I'm screen recording. So the output power is 75 watts. Output current, 5 amps. I wasn't able to test that because like I said, I didn't have a proper load. I didn't have a DC load or a light bulb or something. Conversion efficiency, 96%. No, sorry, don't believe that. Yeah, so that's that. And if we go back up here, you can see there's a US direct link, and that will take you to this Amazon page. And you can pick it up for $9 from Amazon.